And we're live. Right on. I got holy smokes, bunch of people on this call. Rovan has been doing his usual excellent work in the social media piece, and I see we got a bunch of questions already. But
Cool.
first, Mike Horton, welcome, man. Good to see you.
Good to see you, Nick.
Yeah, I'm always psyched to talk to you about GNSS, GPS stuff. Every single time I learn something new. For folks who haven't seen GeoDNet before, let's do a super fast overview of what it is and how it works for people who've never seen it before.
Yeah, so GeoNet is what's traditionally called a CORS network, a continuous operating reference station network. This is a network of GNSS stations or GPS stations that simply listen to the GPS satellites, and that data is then used to correct the accuracy and improve the accuracy of other GPS receivers in a zone around that station.
Cool. And what we've done, or what you've done with GeoDNet, has been to help people around the world basically contribute to that by adding in a base station. Is that right?
Yeah, so we've followed the DePIN model and letting people basically add to a growing global network of stations. The goal to be the largest network of GNSS stations in the world to provide continuous, uh, correction data for GPSs, whether it's your cell phone, car, or industrial equipment all around the world.
Okay. Love it. Love it. And so far, we're GeoDNet's doing pretty well, right? We started with zero a year ago, and
Yeah, we're coming along. It's definitely the network's improving every day. We've got more people starting to actually use the network, which is super exciting. And definitely the number of stations online has been steadily growing. And we're working away on making sure that the network is a really high quality, really super usable product that industries from everything from consumer through automotive through industrial to even scientific uses can all benefit from the data being produced by the miners throughout the world.
yeah, it's rad to see. We just had Max come in. Max and I have been helping out with GeoDNet, doing some consulting on the messaging and incentive side. It's been super cool to be able to lend our shoulder to the wheel on that. And I saw one of the very first questions was about the details of the NFT for capturing a hex. Um, so what we wanted to do with this, Mike, is kind of just do updates on GeoDNet. Is do like a really broad thing. Hey, this is what it is. This is how it works, and then see what the latest is in the project. Max and I get to see it every day, but not everybody gets to see that. So yeah, walk us through kind of what you see going on right now.
Yeah, I think in general we're kind of entering into a new phase in the project where we're starting to have more and more people using the network. We started off with one enterprise customer where we sort of wholesale data back to them. Now we have multiple people using the network. We have folks in the drone space, more surveyors, farmers, all starting to actually use the network. And we're going to ramp up to a more commercial launch during the year. So I think that's really key because that drives everything. It makes the whole ecosystem. It completes the loop of the ecosystem. On the hardware front, we've pushed forward to upgrade to triple band. Triple band basically is the most high accuracy capability that you can possibly do. When you think about your car, your phone, these are either single band or dual band GPS receivers. So a dual band miner is sufficient to support those. But guys in survey and farming and the higher end of the marketplace where there's a lot of money spent have been migrating to triple band, where you have all three of the operational bands of the satellites, including the newest L5 signals out there. And so we've been upgrading stations with a little mini PCIe card, and that's gone well. Basically, existing miners can upgrade to that and receive additional token rewards, and we have customers who are really excited about that higher performance, higher accuracy data stream coming out.
Yeah, love it. Max Riven is telling you not to look so strong, so stop flexing. That's funny. Okay, so one of the things, Mike, that we saw a couple days ago around another YouTube video was someone was saying, "Hey, aren't these RTK networks already free and available from the U.S. government? Like, why do we need one of these things?" Let's make sure we
Yeah,
address
so
that.
there definitely are public networks out there. They tend to be very old. So the satellites in the sky have been upgraded, and the networks that are on the ground today are called what are not they're not modernized. They don't have all the signals. A lot of the ones in the U.S. are GPS only, and there's constellation now from the Europeans called Galileo, Russians GLONASS. Chinese beta, our stations receive all of them, and that translates directly to performance and accuracy in the field.
Yeah. Yep. So there's free stuff, but the free stuff is not as good as the new stuff, and you end up paying for the new stuff. Is the kind of
Yeah, and
takeaway.
another thing that we hear a lot about the free networks is that if you're a single user and you want to get on there, you can send an email in and get an account. But if you're actually a commercial business that's going to try to deploy a fleet of e-scooters using the technology or cars, those networks aren't set up for a high volume mass market usage. And they're not super reliable. We're actually monitoring a lot of the stations that are publicly available and tracking them to understand, to just use as kind of reference points in our network. And we do see they go up and down a lot. The number of satellites they track is typically, 10, 15. So it's a different ballgame. If you look at a well-installed GeoDNet station, it can be up to 50 in some locations. So really, I think we do offer a lot of value there. We talk to customers. We don't really hear, oh, we want to use a public network. They want to use a global network. Another point is these public networks tend to be kind of regional. So California Department of Transportation has a network set up. That network actually is only available for California Department of Transportation workers. So they don't actually allow any public access to that. But these kinds of networks have been around. But I think using DePIN, we're able to make a global network that's available to all, that's also fully modernized for all the latest satellite signals, which is a huge contribution.
Yeah, it's pretty rad. Max, what you thinking?
Yeah, so one of the things I like to always look at is like what are the actual uses and what kind of clients exist. Mike, you've talked about kind of lane level accuracy on GPS. For cars that are driving on the highway. Can you talk about that a little bit?
Yeah, so
that was a terrible first question, by the way, in the history of the show. Well, it's only up from here.
Yeah. Sounds good. When you drive your car, you'll often notice that the position of your car on the map is kind of showed as a little bit ambiguous because the GPS system doesn't know which lane you're in, and that limits the level of detail that the driving directions can have. So lane level driving directions really relies on improvements to the GPS, which would come through something like a corrections network like GeoDNet in order to more precisely position a lane. Your car has maybe a meter on each side of the lane. So if you want to do accurate lane level positioning, you'd like to have accuracy down in the sort of 10 centimeter range, which is very doable with GeoDNet corrections. And so that's definitely a use case that's coming up. Cars are starting to use GNSS corrections in systems today for both autonomy, but also for simple things like just driving directions, which we all would wish were perfect.
Yeah. I'm seeing this nobody nothing guy saying I've had GPS tell me I'm in the river.
Yes, indeed.
Yeah, it's like I don't feel wet. Is triple band the limit? Yonex 2628. Is there going to be a quad band coming up or a quintuple band or something like that?
I mean, the only other band that's out there is this band E6, which is kind of an L band, and it's for actually distributing corrections back down. So normally you think of the actual data from GeoDNet coming through the internet, so like a 4G modem, or could be LoRaWAN in the future, but typically like a 4G modem in the car or on your cell phone obviously has internet connectivity. There is an additional band that's interesting in the rover side, not so much on the base station side, but on the rover side that can be used to actually receive corrections. And so one of our customers actually broadcasts their own L-band signal, which allows then people to get correction data without any internet connectivity, if the receiver tracks that. So that additional band would be something useful on the rover side or on the mobile device side, but not so much on the base station side. So I think triple band is what you'll see for the base stations for the foreseeable future.
Okay.
And then Mike, for those. Oh, yes. Just for the people who this is their first time hearing about GeoNet, can you explain the rover a bit?
A rover is just whatever is moving. So the base station's fixed, right? The GeoNet network is a network of fixed reference stations. and the rover is whatever's moving. So the rover's your cell phone, the rover's your car, the rover's your tractor, if you're a surveyor, the rover's your surveyor stick. It's just an industry term to say that device is moving around, and it's the one that wants to get the really accurate position. The fixed devices are fixed. The rover is moving around, and you would like that rover to be positioned as accurately as possible.
Got it. We get questions about what the accuracy is like, and I think this is one of the coolest things about this project is that most of us think a GPS is like, it's pretty accurate. It gets me to pretty close to where I'm going. But how accurate can it get?
Yeah, so centimeter. So I mean, if you have this is a typical survey receiver rover, as we would talk, that you would see people doing out in construction. They care about centimeter accuracy. They want to know. They're actually required to be able to tell where a point on the ground is to literally 1 centimeter, including vertical. And typically vertical accuracy in GPS is actually quite poor due to the sort of geometry of the satellites being very far away. You get the worst accuracy in vertical. So 1 centimeter accuracy, roughly 100 times more accurate than what you would get without a GeoDNet.
It's bananas. It's bananas to think of that. And I didn't even think about the vertical side. Is there a limit to how high it can be vertically? Is it like after 10 meters, it starts getting 10 meters from
Nope.
the earth, it starts getting less
No,
accurate?
no
I guess it
limit.
shouldn't matter.
I mean,
Right?
there's an export control limit on GPS at like 60,000 feet, I believe, something like this, where the civilian GPS system cuts out so that people wouldn't be doing things that are really crazy with it. But other than that, there's also a super high speed limit that's also like Mach something.
Okay.
But as long
I got
as
to
you
worry about. Yeah.
1,000 feet and don't go Mach XYZ, you're good to go. You can get your centimeter accuracy anywhere.
No rovers on the SR-71 Blackbird. Fair
Yeah,
enough.
exactly.
Okay, let's see. Ilja Safanovas is asking about Australia. Said there's a lot of devices joining the network at the same time. Is that a company?
Yeah, it's something we can talk about, and we'll do some more announcements with them. So we've entered into basically we've been working with Geosciences Australia, and that's a group a trusted group in Australia that is part of the government there that's put out quite a large network. It is a unique public network, and that it is fully modernized and it is very dense. And we've been working with them now for some time. They have an open source software package that we've published some results from called Geonet, and I'd be happy to share that from our last Institute of Navigation meeting. So we've put their stations onto the network.
Okay, very cool. Super cool. Let's see what else. Oh, you said what's an L band? Not all of us are geoscientists.
Yeah, so L band is again, if you want to get correction data, your normal choice is to use 4G, use mobile internet connectivity for the rover. The data stream isn't particularly large, and you can receive these corrections. But say I'm out in the middle of nowhere and there's no cellular phone coverage. Well, you have a number of different choices, and one choice I know you and I, Nick, have talked about is trying to leverage the LoRa networks out there to do this, and that's a super interesting possibility down the road for GeoNet. But the traditional way that people solve that problem, whether it's in offshore or agricultural area where there's no internet connectivity, is they use L band. And L band is basically just like the GPS signal. It's another band coming down from satellites. Most typically, L band comes down from Inmarsat, which is a private satellite company. But there's also L band signals now coming off some of the European satellites and some of the Japanese satellites. And that allows the GPS receiver itself to receive correction data. And that it's slow. The satellite radio channels are slow, but it doesn't require any connectivity. And that's what's really cool about L band corrections.
Got it. Okay, I always think of it as a triangle where the satellite is up at the apex of the triangle, and then one side is the stable miner or the base station, the other side is the rover that's moving around.
Well, imagine if you just took the base station data and sent it back up to a satellite to have it sent back down again. And you can do something like that with Starlink as well, but the Starlink is pretty big and not very friendly to attach to your mobile phone. So the idea with L band is the same radio that's inside the GPS receiver could receive corrections, albeit at a very slow rate, through the satellites themselves. Yep. So it's
and is there a speed requirement for that, or is there a bandwidth requirement?
It varies depending on how exactly it's implemented, but typically it's like 600 bits per second, which leads if you use L-band for high accuracy, it leads to basically a warm up or initialization time of something like 15 minutes. You can look
Okay.
at the sort of PPP L-band services. Now there are ways you can try to speed it up a little bit, but it's not typically not as fast and not as accurate as what you would get if you had corrections coming over 4G, where you don't really have any practical speed limitation. You can dump all the best data to the GPS receiver very quickly, allowing for really instantaneous, like within 1 second type of time period convergence to 1 centimeter.
It's crazy. I mean, it all makes sense because it's like, if you're out in the middle of nowhere, it's going to take a little bit longer to get information out to the middle of nowhere. That
Yeah,
seems fair.
basically that's it. Yeah, that's exactly it.
Let's see. All right, so we did the rover, we did the L-band stuff. One of the things
So,
Max and I wanted. Go ahead, Max.
oh no, you go ahead, Nick.
I was going to say one of the things that Max and I wanted to do with these is get updates on the project. There's been a lot of calls that you've done. You've been really good about doing the FAQs the AMAs, typing those up with Roven, so anyone who wants to get on the Discord can go kind of figure out what's going on. But it's always nice to get kind of in-face time and say what are you psyched on for the next, I don't know, 1 to 4 months.
Yeah, a couple of things I wanted to highlight again. I wanted to highlight again increasing usage of the network, and we're redesigning the website along those lines to really make it more friendly to the side of the market that wants to actually use the network. The second piece is we're building out the Raspberry Pi based ecosystem. We'll have more announcements coming on that. But one of the things we see, there's a ton of Pi 4s in the field from other IoT projects, and it's just a really popular, versatile platform. So we're
Yep.
building out a set of, building on top of the sort of mini PCIe card. We're building a card that then is a Pi hat. You got the mini PCIe, plug-in capability. It's a little hard to see here, but
Yep. Yep.
you plug in your mini PCIe into a little Raspberry Pi hat. Then you can take your Raspberry Pi hat and connect it up to your Raspberry Pi, and there you go. You got something that's now a capability for a miner or for a base station or for a rover over time based on the Raspberry Pi. So we're working hard on that. I think we're going to start off with it really focused on the rover side because the additional CPU capability of the Raspberry Pi lets you run things like RTK engines in there. It lets you run camera software to log data, all the kinds of things that people in robotics want to do. It's a versatile robot operating system, also known as ROS, can run on the Pi. So it's a real versatile platform for building up systems that can build on top of GeoDNet. And so we're excited to bring the Raspberry Pi into the kind of GeoDNet ecosystem. For those that don't know, the first generation of miners that are out there, they're also on a great platform, which is the ESP32. But that's a platform that's great for taking data from the GNSS receiver and getting it out onto the internet for a correction network, which is what GeoNet is. But the ESP32 is very limited on computation capability, whereas something like the Raspberry Pi, it's a Linux platform, can do a lot more things with it. So it's perfect for helping people who want to use GeoNet, DIY, all kinds of different solutions. So those,
Yeah. Hey,
those
so I'm saying. Oh, sorry. Go ahead.
Yeah, those are the two, I think, things in the real near term that are coming down the pipe. We got some things a little bit longer term working away as well in terms of additional capabilities that we want to bring. We ultimately do. We've talked about it a number of times. Want to do the integration of GeoDNet and LoRa, which I mentioned before, but that's still a little bit further out.
Cool.
Yeah, so I'm seeing some people talking about token listings and token price in the chat. I don't want to put that question to Mike. I just want to say that, it's obviously a very important thing. It's something a lot of people care about, but just for this show in particular, it's not something we talk about or really care that much about. We really want to talk about what's going on with the projects and how they're operating and where they're going in terms of the actual project. I'm sure there will be other places that will want to talk about tokens and charts and all that other stuff. That's just not what we do here.
Yeah, and I'm super psyched to talk about using this thing. So let's walk through, Mike, one of the cases that we've talked about, which is this nursery and figuring out where this plant nursery, figuring out where all their different pots are and using that centimeter accuracy to figure out exactly where they are. And that's a really cool thing where I'm taking sensors that are on the helium network and putting them on plants, and then we use GeoNet to figure out where the plants are, and start to combine these two networks. And that combination is what I want to talk about, because there are pretty big implications for using the security of what GeoNet can offer as far as proving where a thing is when it comes to helium. So would you walk us through, I know you've walked me through it a bunch of times, walk me through it, humor me, walk me through it one more time, is this idea
Sure.
of the ephemeris piece, what it is, and then how it helps keep the
Yeah.
location part secure.
I think the easiest way to understand how GeoNet helps is to first kind of go in the reverse direction and think about, well, what if I want to hack GPS? What do I do? And there's some good videos on YouTube that walk you through it. There's a whole industry around not really hacking GPS. There probably is a dark web industry under that, but there's
Yeah.
certainly an industry around simulating GPS, and that's kind of where it starts. You can get a device like this that will basically play GPS signals out the RF port. And GPS and GNSS, these are one-way networks. They only transmit from the satellite down to the rover, right? The rover doesn't talk back,
Yep.
and they're unencrypted. So it's an open radio network that anyone can dial into with a cell phone or a car or whatever. It's also a network that anyone can pretend to be a GPS satellite by transmitting those signals. And so you go and you get one of these software-defined radios, and there's a nice project called GNSS SDR that's used for a lot of really great purposes, but it's also easy to use it to spoof GPS.
Yep.
Now, when you think about that, though, the first thing that comes to mind to you is that is a replay attack, right? Is essentially you are going to broadcast satellite signals out as if they were real, but it's kind of a replay attack. And in particular, the navigation messages, which describe where the signals that are in the sky, those are not known ahead of time. So the U.S. Space Force transmits them up to the U.S. satellites. Chinese military transmits them to the Chinese satellites, Russians to the Russian ones, Europeans to Europeans. No one knows that data ahead of time. So by definition, and if you go through the video and you do it, you'll see you go to the JPL website, you get the ephemeris from a few minutes ago or a day ago or whatever you want, and you plug that into your GPS simulator and you broadcast it out. And that's how you spoof GPS. But we have a network of trusted stations all over the world, and we're cryptographically signing the data on those stations. So we basically get the ephemeris first, and we can use that as a way to prove location. If we see that those ephemeris messages, which should be the same for everybody, are different on the device, well, we know that data isn't real, and we're detecting essentially somebody using something like a simulator or a hack
Yeah.
RF to spoof the signal.
How many networks can do that? Can every GNSS network can do the same kind of thing?
Um, Potentially, the one major difference that I think is different is we started off with this sort of, every miner has a crypto chip in it. And I don't think there's any other network in the world today that is built that way. I think they've all been sort of built up in a professional way, in a secure way from a professional enterprise point of view, but not in a trustless, permissionless blockchain style way, where you work for an assumption that the people who are asserting a GeoNet station may in fact be adversarial.
Got it. And it sounds like it's super difficult to put a station in and pretend it's somewhere else. Like that's the whole point of the station, is to say that it is where it is.
Yeah, I mean that's the point. It's pretty well described in our white paper as well. But this is the point. We want to make sure that any station that's asserted is real. So we're doing things both both at the RF port level and at the miner level. The RF port level being this use of the navigation messages to secure the location of the station, and then you can then in turn use that to secure the location of rovers, and really prevent the types of attacks that you do see. And I'd be happy we can put in the chat some of the YouTube videos that are out there that do show you how GPS spoofing works. And those videos are, I think, pretty educational, because if you go through them and do it, you end up understanding really fundamentally how the whole system works. And then by turn, you can understand how Geonet works as a proof of location service to secure location.
Mike, can you talk about the density of some of the stations that are being put up? Obviously we want to have one within a 10-mile radius of another one, but if there is more density in an area, does that provide any more precise data? Is there any value to that?
Yeah, I think
Can you
it,
speak
it
to that a bit?
provides a couple of key values. So we're not we are going to scale rewards over time to where there's too much density, because it's important to have good balance in the ecosystem between um, users of the network generating revenue and then miners. And if you have way too much density in one area, you can break that balance. But on the other hand, extra density certainly doesn't hurt. There are two areas where it helps a lot. So you can think of your phone as being kind of a arch a really good example of a terrible place to have a GPS receiver, right? It doesn't have a nice big white antenna like the survey receiver, right? It's not a nice
Right.
big beautiful antenna like that. It's actually the antenna is actually part of the mechanical design of the phone, and it's a really terrible antenna. So it's hard to get good accuracy for the phone. And so in that case, the closer the station is, the better. And so there's an example of where if you try to improve the position of the phone with a station that's really far away, you're really not going to make much of an effect, whereas a closer station is going to have a better impact. So that's one place where extra density biases, and that's a big place, right? Mobile phones is a huge use case. Another place that's useful is when you want to think about detecting people who might be doing nefarious things to the network, particularly like jamming or spoofing. Those can be fairly localized attacks, and the fact that if you have a trusted reference station where it is, and it starts producing data that's obviously wrong or varying from where it was originally placed in a way that is unusual, well, that gives you that signal that signal quality map there that tells you there's a problem. It could be also unintentional. People sometimes put up things that unintentionally interfere with the GPS bands. So that's another place where extra density is useful, and that's something we're thinking about. We've actually been in some discussions now there on that type of data product. That sort of public security data product is a real thing. There's a real need for it.
Got it. Got it. Let's see. Let's do it in order. I'll do the decentralized Rob one, Max, and you can do Siegfried's. Rob is asking how many satellites need to be can be picked up in an ideal situation? Like, is there a maximum? Is there a record number of satellites that a triple band can pick up?
Yeah,
And
it's
what's the
somewhere.
minimum?
The minimum that we have for the rewards is 30. And going back to that earlier question about free networks, if you look at some of especially in the U.S., some of the public networks that are out there, a lot of times they'll be at like 12. So when you're contributing an earning tokens, you're outperforming a lot of stations, a lot of older stations that are out there that might be GPS only or GPS GLONASS only. So 30 is the minimum that we need. The most I've seen is like maybe 52, 54, and those tend to be in the Asia area, where there's just a lot of there's a little bit more typically in the sky density of these satellites. They have a lot of Beto satellites. A lot of the QZSS are really only in that region. So those things, you can see them push up to 54, 50, something like that. And that's a lot when you think about it. It's
Yeah.
really a lot of satellites.
Yeah. It sounds like the Chinese are crushing on this whole GNSS thing, which is it's cool. I mean, we kind of advanced humanity in that way, all working together to figure out what's going on and sharing that with each other. Max, you want
Yeah,
to
and
hit the Siegfried's question?
yeah, Siegfried, an interesting question that we've kind of talked about internally at GeoNet, and it's how well can these the cryptographic chip that signs the data, how easily could that be added to a helium hotspot to confirm the location of a hotspot and reduce spoofing?
I think pretty easily. I mean, you could think of a USB stick add-on to a lot of the existing miners that are out there. Um, we could, think about some kind of secure handshake between the two if there was a LoRa radio, or there's, I think, a number of different ways to go about it. We'd like to see that happen. I think it's also pretty interesting on the mapping side. I think that'll be important to also have, if you're doing mapping and doing serious mapping, it's pretty important that the quality of that data is really trusted and secured. So yeah.
Totally able to do it.
Cool.
Ilya's got this question. I think I'm saying that right. Ilya, ILJA. I'm assuming it's not Ilja, but maybe it is. I think this is a cool chance to dive a little bit deeper into how it works. He's saying, does every pixel, and which I'm assuming is a phone, or your phone, does every pixel in the area have to be filled with at least one device with a good antenna setup to provide quality GPS, or can it be not so dense and still qualify as a good network? And I think there's a couple pieces to unpack there.
Yeah, I think that if we're denser in most in a lot of areas, we're setting a new standard for density. So traditionally, the industry has been fighting against this idea of density for a long time. So if you look at the sort of innovation of how people have been trying to solve this problem prior to GeoNet, it's been to move away from density and to try to achieve similar level results with less density. So the answer to your question is, definitely you can do a lot, especially with the triple band miners, without every hex filled. As you get further and further away from any station, yes, the accuracy will degrade. There is a formula that has been used for ages. It's not a perfect formula in terms of being exact, but it's a good rule of thumb, which is that your accuracy is 1 centimeter for every 10 kilometers you are away from a station. So if you don't care about 1 centimeter accuracy and 10 centimeters is good enough, you can be further away from the stations than if you care about 1 centimeter. And so you see guys who are doing like paving and surveying, and they're always really concerned about the absolute best, the absolute best accuracy, whereas some other applications maybe a little bit less accuracy is okay.
Got it. And I think there's a part in there, just making sure that people know kind of what they need in their device, in their rover, whether it's a phone or a car or whatever. It needs some basic hardware stuff, but that's not really what the dependency is on. It's on whether or not that phone, Apple has paid for the correction stream. Is that right?
That's the basic thing. I mean, the modern smartphones, all the new ones coming out, all have a dual band receiver in them. And Android has made the data open, so we're doing some work there. That's also on our roadmap, and really exciting to see that's now open to everybody. The hardware is there. As I also mentioned, most of the cars are being now produced with the dual band receivers. And you can even do RTK with a single band receiver. You don't have to even have dual band, but it just works better and more reliably and becomes a more practical thing. So I think the rover side hardware is there. Having a ubiquitous network is going to really help adoption of the technology. And once people sort of see the benefit of higher accuracy, it's hard to go back. It's one of these things, once you've tried it and experienced that this thing can work a lot better than it normally does, it's hard to go back.
Mike, what do you see as kind of the medium to long-term vision of GeoNet as because as these projects kind of expand, the goals are different, but like, what is the best case scenario at 10,000 stations and 20,000 stations and 100,000 stations? And at what point is there like now total global coverage?
Well, certainly by the end of the year, we'd like to get past 5,000 stations, and that will put us on par with the largest networks in the world. And so I think that's really something where we're not, sort of trying to be an infill network or covering places that wouldn't be. Even by the end of 2023, there's a really realistic chance that we'll have the most stations of any single network in the world. And then from there, the reality is that these RTK networks don't provide global coverage today by any means. So the next step after that is to look to how do we get to a network that does provide complete global coverage, and the long term is to get to 100,000. But once we pass that 5,000 mark, we'll be starting to sort of just be bettering ourselves, and so we hope to get there by the end of the year, which I think will put us in an extremely strong position to consolidate more and more usage onto GeoDNet, which is really the goal.
Dig it. All right, I got 2 questions here. We got our buddy Chats in there. Chats is the guy. Remember, he said he's going to turn in his geospatial degree if anything that I had said was wrong, and there's like anything I said was right. So Chats, I got to give you an address so you can send me your geospatial degree, because I think there's at least one thing in there. But you're saying, let's see, you would never use GNSS for paving. You use total stations. What's a total station?
A total station is a laser-based instrument. So
okay.
It is basically to it's even more accurate. It's millimeter accurate. So you set up, it's like a LiDAR.
Right.
Think of it like a LiDAR, but it's a total station is purpose built for construction. Now there are a lot of people in paving that use GNSS. I mean, that's definitely most of those guys will set up their own base station, but
Okay.
that definitely, yeah. I mean, in fact, the company Tursis, whose device I've been holding up as an example of a survey receiver, they definitely have an OEM partnership with one of the paving guys. So there are people that do it. It definitely is. It is an example of the application that really pushes the accuracy, particularly the vertical accuracy, to the absolute limit, because people want their pavement smooth. They want it really, really smooth, and so a total station does even better, but it's harder to automate. And I think there is a trend to use GPS, precise GPS in paving, very much so.
Cool. Chats. I'm assuming Chats, you're the same guy who've been arguing with. What do you got, Max?
There's a question from, it looks like KE7in. I don't know if I'm pronouncing that right. Asking about the NFT, just kind of how that works and how it'll help early adopters. And I guess, what stage it's in. I'm just kidding, Kevin, I know.
Yeah, NFT is a huge win for early adopters, and that they will, once they get the NFT for really setting up a station and getting the station to work to commercial grade. So we can trust that is a really good install from a satellite coverage and internet stability point of view. They're going to get an NFT, which means that they will never, in that hex, they will always get 100% rewards. Anyone else that comes into that hex, there may be additional rewards in the hex available, but it'll be at a fraction of the rate of the NFT holder. So the NFT holder is basically guaranteed to whatever the current mining rate is that they can get. If they keep the station online and working well, they can get 100% of the rewards, and they don't have to worry about their neighbors setting up a station and sort of taking their rewards away from them. And that's what we really want is a set of well-distributed, really good quality stations. Extra redundancy is great, but it's not as great as each hex having its own really good station, which has been something that's been hard to achieve for DePIN projects. So we're doing everything we can. The NFT is one thing. We're looking at other things as well to really try to promote really high quality, even coverage, because that's what people pay for, right? I mean, no one wants a network that's really super covered in one corner and not covered in another. That is not nearly as valuable. That's exponentially less valuable than a network that has really good, solid, even coverage and is performant across a wide area.
Yeah. Dig it. Anything else, Mike, you want to hit before we wrap this thing up? I'm seeing a couple questions about changing triple band does not affect the NFT. I don't think it does. But anything else kind of in the future? I think one of the things we want to do is like, hey, here's some updates on GeoDNet that you're ultra pumped on.
Yeah, I think I'd highlight the work going on to further develop the mobile ecosystem is one that we're super pumped on.
Yep.
We're definitely pumped on trying to work with the community and listening to the community, being a real decentralized project.
Yep.
So we're trying to aggregate more resources. I know that I've seen a few people in our Discord claim that we're going too slow and it's not as fast as people would like. And I get that. There are definitely some headwinds in the market, as we all know, in the crypto market, but we are really a decentralized project and want to grow in that way, and that's something that's really important for us.
Cool. Let's see. When changing to triple band, can it affect your NFT? No, I think it just makes it easier for you to get one, right? Because
a little bit easier to get one, and it also gets you a higher rewards rate. But if you have an NFT from the dual band, you swap to the triple band, you're going to now be guaranteed a higher reward rate because the triple band mines at a higher rate than the dual band. And we don't want to ever create the impression that dual bands are not useful. Dual bands are super useful. So don't feel any pressure to upgrade. It's really, we both are very valuable capabilities. And you'll see when we come out more formally with our service offerings to the marketplace, both of those will be offerings in the sense that there's a set of customers who accuracy is the absolute most important thing. Triple band is the way to go. There's another set of customers where their end equipment is dual band. So, they don't need triple band corrections. They have their your mobile phone doesn't have a triple band receiver in it. It may someday, but not today. So the dual band is perfect for that. So they're both very useful.
Mike, I want to hit on something that's somewhat foreign in the DePIN space, but Kevin brought up a good point that there is real world revenue from real customers in GeoDNet. Can you talk about that?
Yeah, so we have, we kind of launched the project when we had a customer. So we didn't start this thing off just completely. Oh, let's do a blockchain project. We had started an effort to put these stations out, and we realized that the DePIN method could really accelerate and bring the network together. So we have built the project in a completely bootstrapped way. Revenue comes in from people using the stations today. That's
That's how it's supposed to work.
That's how it's supposed to work, and we have a good outlook for that to continue to grow through the year. So now we're up to 3 commercial customers. We've talked publicly about the Hemisphere Network uses station data from GeoNet. Rock Robotic is now out publicly using it for the drones, and also helping people install stations in their marketplace, in the drone scanning marketplace. And we do a lot of work with Quectel on e-mobility and these types of things. So those are all 3, I think, announced. There's been press releases, and we continue to push forward on more, more usage from those customers, and also more customers coming in. And we did the FIRA show, which is an ag robotics show we have coming up. I guess one thing I haven't mentioned that's pretty exciting, we got a paper accepted into FIG. FIG is the International Survey Community. So there'll be a presentation and a paper presented actually by a third party, but using GeoDNet data at the FIG event. And the FIG, we will have actually demonstrations of survey equipment using the GeoDNet network at the FIG Symposium, which is in Florida, coming up in about the May timeframe. And that's really the kind of a marquee event for the international survey community. So we're working on all fronts to bring reputation and understanding that just because it's based on a blockchain doesn't mean it's unreliable or not performant. In fact, quite the opposite, that a blockchain network can be better than existing alternatives, better performance, better reliability, better quality than any of the existing networks out there. That's really the goal of GeoDNet, to be the best network ever built for this space.
It's got to be pretty
I
exciting.
gotta know though.
Yeah, go ahead, Max.
Oh, what's going on with your whiteboard back there? I'm trying to decipher all that.
Yeah, a little physics. We've been actually doing some testing on stuff today, actually riding e-scooters around, doing some testing. So I'm kind of calling in from the lab today.
Love it. Well, we'll close with this teaser question. CCK's asking it, will there ever be staking in the project?
We think so. We've been bouncing a couple of different proposals that are in the reasonably near term around. Not ready to announce anything yet. Of course, there's also, staking has gotten a little bit higher stakes. So we want to make sure we think this through right. It'll definitely be coming out of our DAO, which is located in Singapore. But yeah, I believe so. We believe there's a good use for it in our project.
Dig it. Well, I can tell that a couple folks in there can keep asking questions all day long, but I know you got stuff to do and getting back to mapping the world. So let's wrap this up. If people want to find you and ask those questions, best place to do it is going to be the Discord, right?
The Discord, yeah.
Yeah. Just drop them in the Discord. You guys do really good AMAs, and we'll get those answered. And then we'll have you back on next week after, and just kind of keep providing updates.
Thank you, Nick. I really appreciate the opportunity, and I really appreciate all the support from the DePIN community, and we'll keep after it, and this project's going to be a great success. So really appreciate the opportunity to talk a bit about the project.
Right on. Thanks for coming on. We'll see you guys later. Bye-bye.
Bye.